Okay, so today's lesson is going to involve us using the features that we've been talking about for the last few days, and we're going to use those features, and then we're going to piece together what the graphs of a rational function look like. So I'm going to go through several of the problems from the 4.5 task, and then you are going to work on the 4.5 homework in class once you're done watching the videos and taking notes on the problems that I'm going to go through. So the first one is the warm up. So you've got a rational function here. And what we want to do is we want to identify all of the different features of that rational function in the same way that we did in class and the way that we did for your quiz over the last few days. So the first thing that we're going to identify here is our x-intercept. And we know that we can identify that by taking the numerator and setting it equal to 0. That's going to give us an x value of -1. So I'm going to have an x-intercept at the coordinate point -1, 0. Then we're going to find the y-intercept by plugging in zeros for both of the x's. So if I plug in zeros for both x's, I'm going to get a 1 on the top and a 2 on the bottom. That's going to give us the coordinate point 0, 1/2. The vertical asymptote comes from setting the denominator equal to 0. And that's going to give us an x value of -2. So we've got a vertical line at -2. Yesterday we talked about the concept of end behavior and what it means for a fraction to be proper or improper. Since the degrees on the top and the bottom here, they're both linear, so the degrees are both 1. That's technically an improper fraction, which means we're going to have to use division to figure out what the end behavior is. So our end behavior for a rational function, always going to be x to -infinity and x to +infinity, just like a polynomial. And we're going to figure out what that's going to go towards based off of these degrees. Since these degrees are the same, we learned yesterday in class that we're going to divide the leading coefficients. So in this case, 1 and 1. And we are going to say that the end behavior on both sides goes to that value. Because the end behavior goes to the same thing on both sides, we actually say that we have a horizontal asymptote, and the horizontal asymptote is the same as what that end behavior value is. So piecing together the different things that we've gotten here, we've got an x-intercept at -1, 0. We've got a y-intercept at 0, 1/2. We've got a vertical asymptote at -2. And I've got a horizontal asymptote at 1. So what we're going to do with this table down here is we're going to figure out where exactly in this graph my rational function is going to be graphed. And that's going to be found by just picking values that are on either side of the vertical asymptote. So for example, I'm going to pick a couple of values like -3 and -4. And I'm going to figure out, is this rational function on the left side, is it graphed above the horizontal asymptote or is it graphed below the horizontal asymptote? So if I plug in -3, we're going to get an a y value of 2. So I have a dot up here. If I plug in -4, I'm going to get a y value of 1.5. So I have an a y value up there. So what that means is that section of the rational function is going to be completely above the horizontal asymptote. Anytime a rational function approaches a vertical asymptote, it can't hit it. So it's either got to go up forever or it's got to turn and go down forever. The reason why I know it's not going to turn down and go forever is because there are no x-intercepts over here. If this turned and went down as it got towards the vertical asymptote, then that means I'd have to have an x-intercept over here. Since I don't, I know that it has to turn and go up forever. Then I know that my end behavior is a 1, which means as I go off to the left out here, it's going to get closer and closer to this horizontal asymptote at 1. On the other side, I don't need to plot any more points because I already have 2 that tell me where the function is. It's not going to be up here because I've got 2 points graphed down below, which means that this is going to rise towards the horizontal asymptote. And then as I get to the vertical asymptote, it's going to fall. And so what I end up with are 2 branches of this rational function. Those 2 branches, we call them hyperbola branches. So that's what my graph looks like. Now, if I want to figure out my domain, this is something that we talked about the other day in class. You can actually identify what this is without even graphing the function, because all I need to do is take the all real numbers symbol and then take out any vertical asymptotes. The only vertical asymptote was at -2. So we say that our domain is all real numbers except -2. If you're a person that likes to do interval notation, that's fine. You'd need an interval for numbers that are smaller than -2, and then you would need an interval for numbers that are bigger than -2. And that's completion of the full problem. Once you find all of your features, you can use those features to piece together with some some base knowledge here to figure out exactly where the branches of your rational function would be. So that's the first problem. I'm going to make a series of videos where there's going to be a video for every single problem after this. So if you need more practice, go to the next video and it will be the next problem in the task.